average, and the average will be all of the average, the arithmetic average of all modules and vectors of ZPM resulting from each static position. We could not leave the system on its own to analyze the problem. We included information on some major moments, for example, where there's only one foot on the floor or when the robot is sort of touching the floor with the other foot. That would improve the information, but it's not what we're looking for. And finally, the ZMP final is the normalized or the standardized factor of ZPM. And we have sensors also providing information in all of this stretch, not only about the point which is in contact.
There is another parameter, which is the distance walked. So we need to measure the importance of those factors. We could have chosen an algorithm, I don't know, like multi-objective algorithm, which takes into account those factors. But given the complexity of the problem, the algorithms that do not have this into account are easier to test. And that's why we transform. In order to transform a multi-objective into a mono-objective, we do a media of both of them, an average and a median. So it's like saying someone is happy if it eats well and sleeps plenty. It's not happy only if it eats well or only if it sleeps plenty. So with taking into account minimum and maximum levels, we can obtain a formula based on these two things. Then a physical problem arose. How do we prevent the robot from falling? The robot will not be stable from the beginning because it's going to learn to walk. And for that, we cannot take into account the center of gravity and the amount it has walked. If you fell on the third step, etc., you have to take into account whether it fell forwards, backwards, etc. So we need to, in order to assess the robot, when will the robot fall or why it falls, we decided to get a step attribute. So if the robot falls in the first or second step, it will be rejected and it will not be used in the next generation. The system implementation, well, we'll see. I'm not going to go into much information here. We don't need to, but, well, initially, there was nothing in the market that had the degrees of freedom and the mechanical capabilities that we needed. And so we used a commercial product called Lynx Motion Robot Scout, which has enough, it's bipedal, and it allows us to more or less work with this model. So we needed to adapt servo motors to the joints. We needed to include a servo motor controller. We also had a main controller center that is able to send all the information in a protocol. We also needed to add pressure sensors, distance measurement system, and also we needed to have a radio communication system because we did not want it to trip over a cable, let's say. And why didn't we put the intelligence in the robot? Well, it's possible, there is a system, but it's more interesting to see in real time how it responds, how the whole system responds in an operation system like Windows or Linux. rather than downloading the software in the robot, waiting for it to do everything and then come back. For operation purposes, it was easier to do it like that, even though there's no problem if the whole learning system was in the robot. As you can see, the robot has the lower joints like humans. There is a motor that measures the distance in a horizontal manner, even though, of course, with the rocking, it doesn't measure it accurate. It has no arms, so robots that would have also a harmonized movement of the arms will mean that it would be quite that the rocking would be quite balanced, but we decided to focus on the lower limbs and then would incorporate the arms. The robotic model, it's of a small dimension. It has a main controller, and it has separately a PC that looks at the evolutionary algorithm. Even though, of course, this intelligence part, so this PC could be on in the robot if needed. The robot has an interface that allows to see a specific individual compared to other, or an average of the individuals. It also has a communication control that sends information to the different individuals. Here is the user interface. So at all times we could see what was the state of the sensors, and we could modify the sensitivity parameters. And after doing all this and measuring the individual, we send information to the robot so that it did all of this, and so that it took into account the 0 point, and so that it advanced. This is by the feet. It has an ultrasound sensor to measure the progress, distance made, and then we have actuators, which are easily accessible servo motors, and a servo controller that controls the synchronization between all of them in a parallel manner. We cannot move a sensor sequentially after the other. There has to be a coordinated movement or different sensors. And then for the wireless communications, we had this communication control that you can see on the screen. Regarding the experimental study, the main problem was trying to find solutions that were adapted. So we played with all the numbers until we achieved something that was quite applicable to the system without having to look at the whole problem. So we forced as little as possible the joints in order to have a natural step. We also calculated the algorithms for each servo motor, and we calculated the intermediate movements in order to have a smooth step. So we elevated to 182. Even though the genetic algorithms work with high complexity formulas, these would have needed hundreds of thousands of changes. And given that any of them have to be done physically, it would be impossible. And so we decided to reduce the complexity of the problem. And so we increased the step of the servo motor, and we reduced the range of the servos, taking out all the positions that were not natural, that were unfeasible. Here you have an example of what which are the servo motors. This times 12 is the whole movement, the rocking of the hip, of the bending of the hip, the bending of the left and the right knee, and each of the positions: initial position, final position, and also parameters to go from one movement to the next. However, this is still very high, and so what we decided to do was to increase